today's topic is going to be something that is very interesting. And you are familiar with it, but you might not know. Because if I should ask you, how many of you have taken orange before? Apple before? Yeah, there's something that is essential inside there. Or how many of you have seen oil or fat before? Yes. Some people are telling me, yeah, we use it in the kitchen to cook. Oh, that's wonderful. I'm going to take us to what we want to do today. But before then, let me share some vital information about previous knowledge with you. What can you see here? Here you are seeing different words, fruits here. So this particular fruit you are seeing here, what do they contain? Some have what we call saturated fatty acid. You know when they say saturated, I hope you understand. They are mainly hydrocarbon without double bond. While some have what we call unsaturated fatty acid in there. When you hear unsaturated, what comes to your mind is see that they have double bond or triple bond. Oh, good. Now, some of these fatty acids are present in animal fats. Not only in animal fats, also in what? Fruits. As rightly said before, fats and oils will be our topic for the day. So what will be our behavioral objective? What do we intend to achieve at the end of the day? So at the end of this class, students will one list the source of fats and oil. Not only that, you will be able to state the physical properties of fats and oil and explain what we mean by adding of oil. So let's go to the next slide. Basically here, you have detergents and soap. So detergent and soap. For a detergent, we say it's a chemical compound or a mixture of compounds used as a cleansing agent. As you can rightly see here, we have area, other detergent that you are familiar with. Then we equally have a soap. A soap is a cleaning agent that is composed of one or more salts of fatty acid. You might be wondering what this has to do with fats and oil. But I want to let you know, without fat and oil, all this might be so difficult to be made. Yeah, we are going to expose you to how it is being done. Just keep following me. Good. Now, the source of fats and oils. So you ask me, or I ask you, what do you call lipids? Lipids. Yes, lipids are collective name for both fats and oils. So if you don't want to call them fat and oil, you can call them lipids. And they are used by what? Organism for long-term energy storage. Yeah. Some said, if you need more energy, you take carbohydrates. Some said, no, if you need more energy, you rather take butter or you take some oily thing that can give you what? A long-term energy. Yes, at this point, let me let you know. Basically, if you need more energy, you take fats and oil because they provide you with what we call long-term energy. Are you getting that? Fine. Now, what are these fat and oil? I hope you can see. What do you have here? That is oil. So other ingredients here you are seeing can provide you with what? Fats, and can equally supply you with what? Oil. as we have said before, that most of the fruits contain these fats and oil. So let's move to the next slide. Good. What are the properties of fats and oil? So you need to first know the physical properties of what? Of fats and oil. The first thing is fats and oils are colorless, odorless, and tasteless. Yes, at this point I want to ask you, the one you are using at home, is it colorless? Some people are saying no. Yes. Why is it not colorless? We are going to discuss about it. There are some pigment that is responsible for that particular color in your fat and oil. But basically, your fat and oil should be what? Colorless liquid. Note that any color or taste is due to the association with other foreign what? Substances. The yellow color here, or of body fat or milk fat, is due to carotene what? Pigment. I wanted to tell you before why your fat and oil is colored, because of the pigment called what? Carotene. Note that. Write it in your book. Another thing you need to know is the specific gravity is less than 1. That is why they float on water. You can try it at home. A drop of oil, put it inside the water in a cup. What do you notice? I hope you can tell me. Yes, some people are saying, yeah, it floats. It doesn't go down to the what? Bottom of the water. Why? Because its specific gravity is less than 1. Good one. Hope you are following me. Fine. Yeah, they are insoluble in water. Why? Because they are what? Organic solvents. They can only be soluble in organic solvent because they are organic substances. Therefore, they can only be soluble in what? Organic solvents. Examples of organic solvents: ethanol. Get it? Benzene. Yeah, they can only be soluble in organic what? Solvents. Therefore, when you put your oil in water, it will remain what? Insoluble. Good. Their melting point is low, and also have what? High solidification what? Point. Their melting point is low. What is the meaning? They can easily melt. That is why you put oil in water, oil inside the pot and you put it on fire. What happens to the oil? Start to what? Expand. Yes, start to melt, because the melting point of that oil is low. And when you drop it and you keep it for a while, when the temperature is what? Cool. What happens to it? The oil can start to solidify. So they can easily what? Solidify. Why? Because they have high solidification points. We're going to talk more about what happened to your oil when the temperature is lowered. See what happened to it. Now, this process you're about to see is called hydrogenation of oil. Do you know that your oil can be added into fats and use it to make butter or margarine? So let's see the process together. Okay, fine. So you have the vegetable oil. So the NECO is used. Hydrogen is added in the whole process. So what do you notice? You will notice that when vegetable, which is where your oil is added with hydrogen in the presence of NECO as a catalyst, for what we call the fats or margarine. And this whole process is called hydrogenation of what? Oil. So this industrial process of generating or producing what? Fats from oil. So your butter, your margarine is being produced by a process called what? Somebody tell me. Hydrogenation. Oh, good. Of oil. And this is what you get as the end product. Now, adding of oil. Rightly said before, it just what? Hydrogenation of oil is the chemical process. Note that. I've shown you before, it involves what? Chemical process, where the oil is being added with hydrogen gas in the presence of what? Nickel, to form what we call what? Margarine. Okay, fine. And the hydrogenation of oil, what are those things that are important in the process? You discover that it has a double bond because it is unsaturated. So hydrogen will come in to fill the double bond, the position of the double bond, and turn into what? Saturated fatty acid, which eventually form what we call fats. So what happened again in the process? The double bond is being converted to single bond by a reaction between hydrogen gas and the what? Unsaturated fatty acid. And what will happen to that? It will increase its melting point. Is it only that? No. Produce solid such as what? Margarine, and what? Shorten the chain, the hydrogen, the carbon chain. Look at the process there. We have the hydrogen is being added to vegetable oil. Yes, at about 200 degrees Celsius in the presence of what? Nickel, which is used as a what? Catalyst. And the product is what? Margarine. As you can see over here. Now, class activities. So let's see the question we have on the board. Fats and oils are used as a raw material in the following industry, except paint industry. Will you say paint industry? Example, glycerol is used in paint industry. So the fat and oil is being used in paint industry. Margarine industry, we just explained that. The fat and oil is being used in margarine industry. Cosmetic, yes, the fruits. The fat and oil is being used in what? Cosmetic industry. What do you think will be the answer? Fine. The answer should be what? Plastic industry. What do we use in plastic industry? We use ethylene by a process called polymerization. On this note, I want to say thank you for listening. In case of any suggestion, question, you can contact us on the information on the screen. Thank you for now, and bye.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello students, you are welcome to Eko Learners Support for WAEC and NECO students. My name is Oluwale Kanmashon. I'll be taking you chemical equilibrium.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So our learning objectives for this class is this. The first one, we're going to learn how to define chemical equilibrium in reversible reaction. Secondly, state Le Chatelier's principle. And thirdly, explain the effects of change in temperature. Now, what is chemical equilibrium? We are used to life situations in our environments where children play with seesaw. So in that seesaw, you see a sort of balance where both sides are on equal basis. So from that way, we can know the meaning of chemical equilibrium. A reversible reaction is in dynamic equilibrium when both the forward and backward reaction are occurring at the same time, at the same rate, thereby producing no net change in the concentration of the reactants or products. As I've said earlier, this is a seesaw. These two can be said to be in static equilibrium, whereby the mass of the person on the left is the same as the mass on the person on the what? On the right, which makes it to be in what? Equilibrium. Being in equilibrium, that means one is not placed above the other and the other one is not placed below the other. They are both on equal what? Level. As defined in the reaction, the rate of forward reaction is equal to the rate of backward reaction. Once that is achieved, then equilibrium is what is reached. Le Chatelier's principle is needed for us to know the rudiments. And the principle states that if an external constraint, such as a change in temperature, pressure, or concentration, is imposed on a chemical system in equilibrium, the equilibrium will shift so as to annul or neutralize the constraints. The important thing to take note of here is our change in temperature, our change in pressure, and our change in what? Concentration. These three are the fundamental factors we need to consider when talking about chemical equilibrium. So when there is a change in any of these three, the system will adjust itself in order to accommodate that change, in order to what? Neutralize the what? The constraint. That's what Le Chatelier is telling us. And that will be the basis of what we are going to be working out through this class. Effect of change in temperature. What do you mean by effect of change in temperature? For an endothermic reaction, my students, what do you understand by endothermic reaction? Yes, did I hear you say a reaction where there will decrease in temperature? That is correct. Endothermic reaction is a reaction that leads to decrease in temperature. When an endothermic reaction occurs, there will be decrease in temperature. The environment will feel what? Colder. So in an endothermic reaction, increase in temperature shifts the equilibrium position to the right. What do we mean here? Let's exemplify what. This is a reaction. If it is endothermic, that means my delta H is positive. It has a positive what? Delta H. Now, being an endothermic reaction, the forward reaction is endothermic, while the backward reaction is the opposite, which is exothermic. Please take note of that. Whenever a reaction is said to be endothermic, it is the forward reaction that is endothermic. When a reaction is said to be exothermic, it is the forward reaction that is what? Exothermic. So in this reaction now, the forward reaction is endothermic. I always tell my students to put a clue. This endothermic can be represented by letter D to show that it leads to decrease in temperature, while exothermic can be represented by letter I to show that it leads to increase in what? Temperature. So if an endothermic reaction occurs, for that forward reaction to be favored, according to Le Chatelier's principle, there have to be an increase in temperature, something opposite to the direction of the what? Reaction. So for me to favor this forward reaction, there has to be an increase in temperature. That's what this statement is saying, that increase in temperature shifts the position of equilibrium to the right. Shift it to the right. This is the right. That means, in other words, forward reaction is favored. Shifting the equilibrium position to the right means forward reaction is favored. Shifting the equilibrium position to the left means backward reaction is favored. Let us get those terms correctly. So, forward reaction can only be favored if we increase the temperature. Backward reaction can be favored. Thank you very much. I can hear you very well. Backward reaction can be favored by decreasing the temperature, because the backward reaction leads to an increase in temperature. So that is it. So for an endothermic reaction, increase in temperature, shift the position of equilibrium to the right. That is favors the forward reaction. While a decrease in temperature, as I've said, favors the backward reaction, which is the reverse reaction. These are some examination questions taken from JAM, WAEC. Looking at this reaction above, the question asks us, what would be the effects of a decrease in temperature? If you remember what I've said, this is an endothermic reaction. The forward reaction is D, while the backward reaction is I. It's an endothermic reaction. So the forward reaction leads to decrease in temperature, while the backward reaction leads to what? Increase in temperature. So a decrease in temperature will automatically affect the one that involves increase, which is the backward reaction. Which is the what? Backward reaction. So the backward reaction is favor. As you can see, it is reverse reaction that they wrote here. So backward reaction is favored, reverse reaction is favored means the same thing. So our answer is A. Now, take note of this, my students. There are sometimes in these examination bodies, this option will not be there. You will not see favor backward reaction. You will not see favor the reverse reaction. There are other ways by which they can express that. Favoring backward reaction can also mean the equilibrium position is shifted to the left. As you can see, the arrow pointing to the left. That's one way of expressing it. Another way of expressing it is this. They can say that there is increase in the yield of chlorine and steam. Because if backward reaction is what? Favored, that means at that time, the reaction is producing more of chlorine and steam. So you see it in the option, increase in the yield of chlorine or increase in the yield of steam. That's also an alternative way of writing favors reverse reaction. Another means that they use is to say decrease in the yield of HCl or oxygen. All these are telling us the same thing, that it favors the backward reaction. Now let's go to number 2 question. Consider the following reaction equation. As you can see, this is also an endothermic reaction. The question asks us, if the temperature of the system is increased, if the temperature is increased, that's what we want to solve. Now, if we increase the temperature, let's go about it again. This is endothermic. The forward reaction for an endothermic reaction is endothermic, which is D, while the backward reaction is exothermic. So, for me to increase the temperature, which one will it favor, my students? Is it the upper one or the lower one? Thank you very much. You have given a very good answer. Increase in temperature will surely favor the lower one, the one that involves decrease in temperature. That means the forward reaction will be favored. Remember I told you, without looking at the options, which other ways can this be represented? Forward reaction is favored, can be written as what? Increase in the yield of XY. Thank you. Very good. Can also be written as decrease in the yield of X and Y. And lastly, it can also be written as shift in equilibrium position to the right. Because if you look at this arrow very well, it is pointing to the right. While this reverse arrow is pointing to the left. So shift in equilibrium position to the right. Now let's look at the option. Let's see which one we go for. Is it backward reaction is what? Favored? No. Because what can favor the backward reaction, as you can see, is decrease in temperature. But the question asks us for increase in temperature. Now, the second one, forward reaction is favored. That is our answer. Forward reaction is favored. The third question, this is an exothermic reaction. An exothermic reaction is normally represented by a negative delta H. So in the question above, the yield of ammonia can be decreased by, look at this question. It's very technical. You have to pay attention. It's a jam question. The yield of ammonia can be decreased by, unlike the previous question, they did not ask you what to favor forward reaction, what to favor backward reaction. This one, they're asking us, the yield of ammonia can be decreased by. So you ask yourself, students, what decreases the yield of ammonia? Is it the forward reaction or the backward reaction? Now let's take it one after the other. The forward reaction, what is it doing? Thank you very much. The forward reaction is producing more of ammonia. But the question is asking us, the yield of ammonia can be decreased by. So in other words, the question is asking us for what will favor the backward reaction. Because it's only the backward reaction that decreases the yield of ammonia. So that's what the question is asking us for. What will favor the backward reaction? Now this is exothermic. So the forward reaction is going to be I, while the backward reaction is going to be what? D. So as we have said, what will favor the backward reaction? It is increase in temperature. Because the backward reaction leads to decrease in temperature. So it's only an increase in temperature that can favor the backward reaction. Do we have it in the option? Let us check it. Yes, that's option C. Increasing the temperature. Increasing the temperature, that's what is there. It's different from adding a catalyst. Increasing the temperature is the one that what? Favors the backward reaction. I believe our students understand that very, very well. So these are some practice questions that we can do at our leisure time. This question says, what happens if the temperature of the system is decreased? So the first thing you should ask yourself, what kind of reaction is it? Is it exothermic or endothermic? So since this is a positive one, so it is endothermic. So if the temperature of the system is increased, which one will you favor? Is it the forward or the backward reaction? You answer it yourself, my students, but I'll just give you some guidelines. If you remember, for an endothermic reaction, the forward reaction is endothermic, D, while the backward reaction is exothermic, which is what? I. So what will favor the forward reaction, which is D, will surely be increase in temperature. And this is not increase in temperature. We are told decrease in temperature. So by now, you should have an idea about the answer. So the second one, the following equilibrium is established in a closed vessel where delta H is negative. If delta H is negative, as we have said before, that means the reaction is exothermic. I believe with what we have done, we have understood properly chemical equilibrium.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So for further comments and questions, please follow the link displayed on the screen. Thank you very much.